In the previous video, I looked at the regulations on permitted development and explored how that's going to affect the design of our garden room. I then looked at different options for the foundation and designed a timber base frame to suit. In this video, I'm going to build those foundations and frame. As a quick reminder, I'm going to be using composite post setting concrete as the foundations. This approach is great because I'll be building the timber base frame at the same time as setting out the foundations. As you'll see, it's a really easy way to go about things, and the more I build, the easier it becomes, as the frame essentially becomes my scaffolding that supports and guides me when inserting the posts. With a plan in place, we can then get to work, starting out with marking out the location of that first corner post. Now, the post isn't in the corner of the building, so what we need to do is we need to allow for the offset of the frame, plus the offset of the roof, and then the distance that we need from the boundary. We dug all the post holes as deep as we could manage. In some areas this led to holes as deep as 1 meter, whereas other areas we had much shallower holes because we hit a hard rocky layer. Although we would have liked to have gone deeper in all the holes, we were encouraged that with this hard rocky layer we did have a solid base. We then secured the posts in place with fence post concrete. It's important to get this first post in perfectly upright and in line with the future frame. We found it really helpful on the first post to add these little brackets. They're not structural in any way, shape or form, but we found it really helpful to have something to support the joist while we did the next few steps. We then cut all 4 perimeter joists as accurately as possible, and then by measuring off the boundary again, we have the location of our second post. We could then lower the post into place to mark out the length that we required. One of the drawbacks we found to these composite posts is we found them difficult to cut. The miter saw seemed to be the best tool for the job, and by doing it in the workshop we kept all those plastic particles to a place that we could tidy them up rather than scattering them throughout the garden. The great thing about this foundation approach is the more you build, the more the frame itself starts to help you out. In this case, we level that joist and then put temporary fixings between the joist and the post. This means the post is held in place securely while we concrete it in place. We then bring in the second joist. Using the 3-4-5 method, we can make sure that joist is nice and square, and that gives us the location for that third post. Just to elaborate on the 3-4-5 technique, because of Pythagoras' theorem, if we have a length that's 3 or a multiple of 3, and then another length that's a multiple of 4, and a hypotenuse a multiple of 5, then this corner has to be 90 degrees. For the third post, we need to offset it slightly to allow for that front joist. The fourth post is dead easy. You just bring in the final 2 joists, and where they meet is where the post needs to go. Another nice thing about this foundation approach is you're always able to get fixings into at least 2 sides of each post. In this case, I'm using 125mm framing screws to attach joist to joist and joist to post. I try to bury the screw heads flush with the surface of the wood, so that whatever I might be doing later, the screw heads don't interfere. And there we have it, the perimeter of our frame, all square and level. At this point in the process, we started to second guess this approach, not because of anything we'd done, but rather we hadn't seen anyone else doing it this way. So again we double checked with an industry professional, and again he reassured us it was a perfectly valid approach. He also showed us a few companies that do it this way. Some of the negativity you read about this approach online is solely due to wooden posts rotting and isn't valid with these new composite posts. Also, working through the logic again, we're confident the posts aren't going to move in the ground, as they have at least as much surface area to disperse the weight as any other method. The post should be strong, as the manufacturers assured us it's a structural element, so the only point of concern we have remaining is our connection between the posts and the joists. The screws we're using are rated for this use case and should be plenty strong, but to reassure ourselves we're going to add this little extra block. We're also going to increase the post count from 12 to 15 based on the recommendation of a post for every metre squared. I now need to cut all the joists for the centre of the frame. As I need to cut quite a few of these, I'm going to make a jig. To do this, I'm going to start by putting the saw against the speed square and making a shallow cut. I then measure the distance between the square and that cut. For the life of me, I couldn't work out how to write 35 upside down. I then measure out the desired length for my joist and subtract that 35. I'll then screw a block down at that location. I can then lay my jig on top of each joist and then run the saw up against it to get the perfect length every time. This is a real time saver when you've got a lot of the same length to cut. With our joist cut to length, it's then important to order it. This is important because although this is good quality timber, there's still a lot of natural variation in the timber. Some will be a little bit bent and other bits will be planed to be a little bit thicker than others. The way I like to organise it is by running a block of wood over the top, and if I find a snag, I reorder it until I have a nice smooth transition. It's worth taking some time here because not only will this lead to a flatter floor, it will also be a much easier build. I then work my way around the frame, adding posts and joists as per the plans. I mark out the location onto that perimeter frame of all the joist locations, which then allows me to put all the additional posts onto that perimeter. After digging the post hole a little bit deeper than the post, I then secure the post to the frame. This leaves a small gap between the post and the bottom of the hole, which when concreting it in place I felt gave a stronger connection. As I said earlier, the joists are going to be placed at 400mm centres. That means there's 400mm minus the width of the joist. So if I measure out 400 and subtract a joist width and cut here, that will serve as my spacer. And then because of the way the flooring is going to sit symmetrically from the centre, it makes sense to put my joists in from that centre point. I put a centre line on my spacer jig and on the frame, make sure they're aligned, and then start putting the joists in from there. For ease, each joist is held in place with a single framing screw at this point. I'll come back later on to reinforce that. Next I need to put noggins between the joists. These reinforce the structure and prevent the joist from twisting or moving and reduces the chance of any creaking or squeaking occurring later on. Also, given that we have 3 posts in the middle of our frame, it helps to distribute that load. When designing the frame, I did take some time to consider the position of the noggins. I think this is the best approach as it distributes the force best and for reasons that will become apparent later on. But it does mean that there are a few noggins that need to be secured via screws that go in at a diagonal. Where I have a post in the middle of the frame, I secure a noggin either side of that post. It's really satisfying as you put those final noggins in that it just pulls that frame perfectly square. And once again I use framing screws to attach the post to the noggin. I put 2 in from the rear and 1 in from the front, that way I can avoid the screws accidentally clashing. And to secure the noggins I use 2 120mm wood screws, although I do think I went back and used the nail gun to put a nail in as well, probably not necessary, but belts and braces. Next, I added this full-length beam to the front and rear of the frame. It's important now that all your screws are completely recessed so nothing interferes between the joists. To secure the beam, I clamped it in place and then used 90mm galvanized framing nails every 300mm in a zigzag pattern. I also used framing screws at the ends and wherever there was a post. That way my screw goes all the way through both beams and into a post. I'll then use 30mm square twist nails to secure joist hangers. Joist hangers are where the frame will get its real strength and reduce any dependence upon those screws. I'm not sure how the builders do this, but the best technique I found was to pull the hanger tight up against the joist and then clamp it across, otherwise the hanger likes to splay apart. And I'm sure people are going to call me out on my needle nose plier technique, but it's hard to hold those small little nails in that tight corner without hitting your fingers. So the needle nose plier technique worked out well for me, but if you are a builder, how do you do this? It's worth saying as well that there are 18 nails for every joist, and you should put in every nail. That means this part does take a while. In terms of sourcing the hangers, I found this surprisingly difficult. There are lots of different styles, and there's light duty and heavy duty variants, and the specification doesn't seem to quantify what a heavy duty or a light duty one is actually capable of. The ones I have here are almost certainly more heavy duty than I need, but they were also quite a good price. If you are sourcing them, I'd go for a style that look like these. Also know that a hanger is designed to work for a range of joist widths and heights. The advertised dimensions in the title are often just an arbitrary dimension between this range. And there we have it, a finished frame and foundations. I'll try and update the description with all the products that we used, but if I've forgotten anything or you have a question, please do comment down below. In the next video, I'm going to be digging a soakaway, adding insulation to the floor, and adding a flooring material. Until then, cheerio!